You are welcome to GMAETS 41's live class on elementary. In this class, we're going to give attention to set theory. However, quickly, I would like to state this, please. All right, for any new friend joining us, GMAETS 41 has an online timetable for his classes. Like today, we're actually supposed to be dealing with chemistry. Yeah, chemistry, but this week, I just want us to flex with math a bit. Is that okay? Just flex with math a bit, you know. That is why I decided we should just deal with set theory. And of course, through this week, I am going to be taking you on math. Is that okay? I'll be taking you on mathematics. Then once again, from next week, I will reactivate the GMAETS 41's online class timetable. Is that okay? Mondays, we take mathematics. Wednesdays, chemistry. And then Fridays, we take physics. Whenever it is necessary, for any reason I deem fit, I may just make an adjustment, maybe rearranging the course or subjects that we take any day. But anyway, having said that, I'm welcoming you to this particular class where we are going to deal with set theory. Quickly, there's no time to waste here. I would like to make it very known to you that on this channel already you have pre-recorded video lesson that covers in Unizik, Nnamdi Azikiwe University. I know you guys have just done some things on set theory this week. Yeah, so just a way of assisting those who might have had difficulty in that set theory. And don't forget, on campus in Unizik, GMAETS 41 holds his physical tutorial as well too. If you're yet to subscribe to this channel, please kindly hit the subscription bell icon now, okay? Subscribe and then turn on the notification bell so that anytime I come on live, you will be notified, or I upload any content, you will also be notified. What is set? Simply put, like you've used that word before, is a group, a collection of well-defined objects. It is expected that the object should have similar quality or characteristics. For example, we have this as a set of marker, a group of marker. What is unique? What is common to these guys? What is common is the fact that 3 of them are markers used for writing. Now I can have a set of black marker, a set of black marker, collection of well-defined objects. You can see these are black markers. And I can also use this to form another set. I'll say that this is a set of what? Blue marker. In terms of the color of the markers, you don't expect me to put these 3, markers together. Reason. This one is of different color. This one is of different color. So you have to separate them. So you can form a set of black markers and a set of blue marker. I hope the whole idea of what set is clear now. So whenever I hear of set is not far from what you have known about what the word set is. Without wasting time, let us talk about the types of sets that we have. Please, as I am teaching, often and on, I will go check the camera to be sure that network has not dealt with us. Of course, you know that network can interrupt sometimes. So permit me to check quickly. All right, so we are there. We are there. Once you join this class, like what is happening now and then share the link to your friends. Invite them to join us. No time, right? Now, types of sets. Types of sets. We have a set which we call tabular set. Tabular set. Which set do we call tabular? Now let us look at the word table. Usually if you have a table, it's expected that there you have listed some things, you've written out some things in it. Okay, think of tabulated. Tabulated. When somebody says tabulate something, it means list those things in tables. So the idea of tabular set simply refers to set whose elements have been tabulated. set whose elements have been given have been listed. So whenever you're given a set and the elements of the set are already listed, such set is called a tabular set. E.g., if I give you A to be equal to 1, 2, 3, 4, dot, 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 it continues. Let me say I stop at 10. Good. You see that this set is a tabular set because we know the elements that are there. The elements have been listed. The elements include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since we know the elements, we refer to this set as a tabular set. Now, how do we read this in the first place? How do we read this? Follow along. Let me teach you how to read a set. This is read as A is equal to the set. This brace bracket means set. And we don't use anyhow bracket here. Take note. This is the bracket we use. So learn how to do that corner something there, right? Okay. So A is equal to the set of the element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. Okay, now how about you talk about something like this? B is equal to set of states in Nigeria. Okay, and then let's say a set of eastern states in Nigeria. Yeah, I'm using eastern state because, of course, this class is streaming live from the east, Oka, Anambra State. So let us think about this. We have, what are the states in east? All right, so Anambra, don't mind me, okay? And then we have Enugu, right? And then we have Imo. We have Ebonyi State, Ebonyi. We have Abia. Do we have any other eastern states apart from these 5? The last time I checked, these 5 are the eastern states we have, okay? So Anambra, Enugu, Imo, Ebonyi, Abia. These are the pure 5 eastern states. Or 5 pure eastern states. One could have just said, okay, set B is equal to set of the 5 eastern states in Nigeria. You know, in that case, the states are not listed. But in this case, I have listed the states. So this is tabular set. Look at this one. I can define this set as simply A is equal to set of, I'll write a grammar here. I'll write grammar here. English. Set of natural numbers from 1 to 10. But if I tell you set of natural numbers from 1 to 10, I've not listed them. I just say from 1 to 10. You have to list before you can say it is tabular. As long as the elements of the sets are not listed, that is not tabular set. But if the elements of the set are listed, then such set is called tabular set. Let's look at number 2 type of set. Number 2, we have set builder. Number 2, set builder. Set builder. Now in the set builder form, whenever you refer to a set as set builder, it is the type of set in which the elements of the set are not listed, but are defined grammatically or by some set of rule mathematically. A set whose elements are not listed, but defined grammatically or using mathematical statements subjected to some set of rules. When I told you that this A could simply be referred to as A is equal to set of natural number, I will write it grammatically. Are you getting me right? Set of natural numbers from 1 to 10. That set is set builder because I didn't list the element. I only defined the element grammatically. It is not left for you as a student to list those elements. Find it out. Permit me to check the camera situation, please. Okay. Still moving on. Let us look at some examples. I will still use these two guys. E.g., A is equal to, now here I would say set of natural numbers. Natural numbers from 1 to 10. So this is set builder, because here I didn't list the element. Now we could still rewrite this as, let me use mathematical statement now to express this particular set in set builder form. A is equal to set of the element x. A is equal to set of the element x, such that this colon sign is used for such that. Instead of the colon sign, you can still use this one, slash, to mean such that under set. Such that 1 is less than or equal to x. 1 is less than or equal to x. And then x is less than or equal to 10. X is less than or equal to 10. Now I have to impose a condition of the type of numbers we have here. X is element of natural numbers. X is element of natural numbers. So that someone will know that, okay, this element from 1 to 10 here, the numbers are natural numbers, not just real numbers. Are you following? And not irrational numbers. Not rational and not integers. That these numbers are what? Natural numbers. Now, previous class, I taught you number system already, so you understand what we mean. Look at these two sets. They are the same thing. They are set builders, because I didn't list the element. It's not left for you to list the element you have there. Understanding either the grammar or the mathematical statement. These two sets define this guy here. These two sets. This is the tabular form. And these are the set builder form. Like I said, for B, I could just write B is equal to set of the 5 eastern states in Nigeria. So I want to believe you understand the whole concept of types of sets already. Now when I tell you that 1 is less than or equal to x, the element here, we are calling it x. The numbers we have in this set, we are referring to them as x. So you can generate those numbers that make up x. And this is the mathematical definition to it. 1 is less than or equal to x. Now that statement means the other way around, that x is greater than or equal to 1. So 1 is also value of x, and x is still bigger than 1. So you'll be thinking of 1, 2, 3, 4. But look at x is less than or equal to 10, which means that 10 is greater than x or exactly x, which means you can't cross 10. The highest value of x is 10 because it is also equal to it. Then we are told that x we are talking about is natural numbers. Natural numbers. And that is why you can list them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So take note of that. Most times examiners give you set builder form for you to now bring out what is involved there and solve problems. We are done with types of set. I will wipe the board now. Let's now move on to set notations and look at other key things you need to know. Let us look at set notations. I'm going to be fast in them. Like I said, this is just going to be a highlight so that we can do and then take a rest. Please check through GMAETS 41's channel. Yeah, this particular channel, the playlist. You see the video lesson section for sets, where everything about set has been treated. Now, what are various set notations? We have set notations. We have union of sets, union set, and we use this symbol for it. Whenever you are talking about union of sets, you are putting the element of 2 or more sets together. Okay? So let me assume that I give you A to be equal to 1, 2, 3, and I give you B to be equal to minus 3, let's say 0, 2, 3. Okay? And then I say you should find A union B. It is simply equal to combine these elements together, but do not repeat any common term. Now from here, I can have this 1, 2, 3, then I'll come here minus 3, 0. 2 is here already, so no need of repeating it. 3 is here, no need of repeating it. Mind you, it is not compulsory for the element of a set to be arranged. It's not compulsory. Although just to be classical, most times we arrange it. Are you following, right? So for that reason, I'll start from here, minus 3, because that's the smallest number here. Then after that, we go to 0. I've picked this, I've picked this. Now, if you look at this, you have 1 here, then you have 2, which also exists here, so you pick only one of them. You have 3, which also exists here, you pick one of them. So this is simply the whole idea of union of sets. Let's talk about intersection set. Intersection set. Intersection set. We use this symbol for it. When two sets intersect, your interest is to get the common point. Where do they meet? Are you following, right? Where do they meet? And that is actually obtained from the fact that you know that there is this element here in this set, and that same element is in the other set. That is the point of intersection. That is the common point. So you isolate, you pick those elements that are common. As an example, let us go back to this. We shall still use this A and B. Let's assume that I said you should find A intersection B from above. Are you following, right? A intersection B from above. All you have to do is to come to this set A and B and then ask yourself, what is the element that A has and B also have it? Are you following, right? And here the element will be what? If you look at clearly, you'll see that you have 2 here, you have 2 here. So 2 is common. You have 1 in set A. There is no element 1 in set B. So you can't pick it. 2 and 2, you pick that. Then in set A, you have 3. In set B, you also have 3. So that is also a common element. You pick that. So we have gotten the intersection of these two sets. Let us move on to the next one. No time. Let's move on to the next one. I'd like us to now give attention to complement of a set. But before then, I think I'll have to talk about universal set first. But just pay attention as I talk about universal set. Universal set, like the name goes, universal, is a set that contains every other subset. A set that contains what? Every other subset. I can tell you that you have natural numbers. Natural numbers start from 1, 2, 3, 4, 5, 6. You continue like that. Yeah, if you want to refer to it as whole numbers, you start from 0. You know, if you have 1, 2, 3, 4, 5, 6, 7, 8, it goes to infinity. So you don't even know where that natural number stops. Or stopped, rather. You don't know where it stopped. So that becomes like a universal set to all natural numbers. If I now start picking out some sets from it, let's say I have set A, 1, 2, 3. That is a subset obtained from that natural numbers. So take note, universal set is a set that contains all other subsets. So having defined that, let us move on to, I mentioned complement of set, right? Complement of a set. Now, permit me to define that set as set A. So what is that going to be the complement? So get to know the symbol. This is the symbol. A prime is pronounced A prime. Or you can write it this way. A then C on top. Let me check the camera and be sure that this part is showing. All right, so it's still it's showing, it didn't cut off. Now, the complement of any set is defined as a set of elements in the universal set which are not contained in the set itself. So if I talk about complement of set A, it's simply the elements in the universal set which are not in set A. So here, if I give you something like this, e.g., let a universal set, we use this symbol for universal set, or we use this for universal set. So let me define a universal set to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Permit me to define set A to be equal to the set of elements 1, 3, 4, 5, 8, 10. If I say you should find A complement, let me even define another subset. B should be a set of elements which I can get from here, I'm forming subset, children of something. These sets are obtained from this universal set. If you look at their elements, the element of this A now appeared here. Now I'm going to define B as well too. Let me define B as, let's go as 2, and then I have 5, let me say 6, 7, and then 9, for example. It implies that A complement will be equal to the elements that are in the universal set, which A does not have. The English word complement, to complement something, is to is a kind of assist, help out in the area that the other person is lacking. Oh, you don't have this, I have it, so let me help you. So if you look at set A has 1. There is 1 in the universal set. In the universal set, you have 2, but A does not have 2. So the universal set will complement that A, will help that A. So in the A complement, you have to fix 2. That 2 is obtained from the universal set, which A does not have. Then if you move on, A has 3, A has 4, A has 5. Now, you notice that A does not have 6. 6 is in the universal set. So the universal set will now help. We complement A with it. So in the complement of A, you fix 6. Move on again. In set A, there is no 7. In the universal set, there is 7. So that universal set will help A. Please, just take care. I'm the pity you. Just collect. That's good. Just like GMAETS 41 is complimenting you in your lectures. Yeah. When there are areas of challenges, you can always count on GMAETS 41. Please, if you're a Zik student in 100 level, join GMAETS 41's tutorials. On campus, I hold my Facebook tutorial there. Contact GMAETS 41. My number is available, of course. Get information about the tutorial, about the venue. Are you following right? This evening in our general WhatsApp group, like today, you friends were taught some things in physics. Some people dynamics, some people scalars and vectors, some people work, energy and power. I'll be dropping the links to those lectures in the WhatsApp group just once I am done with this live class. That is why you people should make sure you are working with GMAETS 41 full time. Just imagine the way things are just scattered. Oh, this faculty, they did this part of physics. This one, they did this one. And you have other courses you are still studying. How can you put them together? Plus the fact that you need to follow your studies step by step. So GMAETS 41 will help you. The Igbos will say, let's put them together so that at the end of everything, you go in there in that exam hall and get the GMAETS 41, the A splashes. Nobody can stop it. It is not negotiable. Your first class is certain with GMAETS 41. It is our God and helper Jehovah that does it. Operate with GMAETS 41. Okay? So I'll be waiting to see you contact GMAETS so you become our registered student. We have our full physical tutorial and of course our full online classes as well. Let's get back to business. Now we continue. Observe that here A has 8. So no problem that we are good with that. Then A does not have 9. 9 is in the universal set, so it will be transferred to the complement to assist it. A has 10. 10 is there, so we don't have problem with that. This is the complement of A. Then again, we can find the complement of B. Complement of B, you compare also with the universal set. There is no 1 in B, but 1 is there in the universal set, so you fix it. 2 is in B, 2 is here, no problem. There is no 3 in B, there is 3 in the universal set, so you bring it down as a complement to assist B. Are you following, right? You move on also. 4 is not in B, in set B, but 4 is in the universal set. So to help set B, the universal set will complement B with the element 4. Now there is 5 in B, so no problem there. There is 6 in B, no problem. There is 7 in B, no problem. There is no 8 in B. So in the complement, you bring 8. The universal set with support will help B with it. There is 9 in B. There is no 10 in B. So you bring down the 10. This is the complement of set B. And of course, you know that you can be asked to find A complement union B complement, or A complement intersection B complement. Like you have this union and intersection. An examiner can give you something like this. Define any universal set he or she wants. Give you some subsets. And then like this A and B are subsets of this universal set. Then you're now asked, find A complement intersection B complement, or find A complement union B complement. Of course, if it is A complement union B complement, all you have to do is remember what I did here. Just come to their complement and combine the elements that are there without repeating any common one. If it is intersection, A complement intersection B complement that you are asked to find from here, simply come to A complement, come to B complement, then check their intersection. Which element does A complement have and B complement also have it? Can we just quickly even look at that? Assuming I say you should find A complement intersection B complement from this third part of our analysis, is there any common element there? An element that A complement has and B complement also have it. Is there any common element? Look at, we have 2 here, no 2. So 2 is not common. We have 6 in A complement. We don't have 6 in B complement. So 6 is not common. We have 7 in A complement. No 7 in B complement. So there is no common term in terms of 7 there. We have 9 in A complement. We do not have 9 in B complement. So you see clearly that there is nothing that is common to A complement and B complement. Therefore, the intersection will mean nothing. And that we use empty set to represent. Either you use this symbol or you use this symbol for empty set. What are we trying to say? We are saying that A complement intersection B complement, the common number in these two guys is nothing. Empty. Because we did not see any element that A complement has and B complement also have that same element. We did not find anyone. And so you now use empty set. So I've told you another set notation, empty set. When there is no element found there, now say it is empty. Okay, we are done with this. I'm going to wipe it soon. Let's move on quickly. Rector Winslet, just subscribe. Thank you so much for supporting the channel by subscribing. You are welcome to join our live class. You're welcome to join our live class. I will be wiping this now. Let's move on to another concept. We are done with union. There is this type, a set notation I would really like us to deal with. You know, most times this set notation is not usually pronounced. It's not usually pronounced when dealing with set. Most people are not used to it. So perhaps I'll quickly just jump into that set notation. Remember, this is a summary, and of course, we'll keep moving. I don't want to keep you so long. Although our live classes, please take note so you are aware of what GMAETS 41 does. Our live classes usually take a maximum of 1 hour, 30 minutes. So we are nowhere close to the end of the time yet, but think is going to be shortened for today. So people should go and warm up. I'll finish this course between now and 31st of December. That's why I told you, if you are not a channel member yet on diamond level, please make sure you become a channel member on diamond level. And once you become a channel member on diamond level, send me a message. Specifically for Mat 101, let's deal with it, okay? Our Nigerian friends, the diamond level is just 4,000 naira monthly only, you see? Very affordable compared to the quality of what you get from this channel. Now, I want us to talk about difference of two sets. Difference of two sets. Difference of two sets. Let us assume that the sets are A and B. Whenever you're talking about difference, I will now take it further into another special type of difference called symmetrical difference, okay? Now, let's have this set A and B. Set A and B. We use something like minus. Yeah, let me just fix minus for difference of two sets. Let A be equal to the set of element 2. Okay, let me make it minus 5, minus 3, then 1, or let's say 2, then 8. Then B, let B be equal to the set of element, let's say minus 3, 1, 8, 9, 11. Now I can ask you to find the set A difference B, or find the set B difference A. Whenever you're talking about difference between two sets, it is simply the elements that are in this set which this one does not have. Difference between these two sets. What are the elements inside this blue set that this black does not have? What are the elements inside this black set that this blue does not have? That is the whole idea of difference between two sets. So if I ask you to find blue difference black, it is simply the elements that are inside blue that black does not have. And if I say you should find the set black difference blue, if you are representing it, it will be black minus blue. Are you getting me right? It's simply, if I say find black difference blue, that refers to the element that black has but blue does not have. So can we work on that here and see? Permit me to check the network situation, please. All right. Still intact. That's good. So it implies that if you're asked to find A difference B, this is how we write it, A difference B. If it is B difference A, you write B first, then minus A. Are you following, right? So A difference B is equal to the element that A has, but B does not have. So this is equal to the set of elements. Let's go back here and check. That reminds me, before I finish, so you'll be warned about this. Some persons misinterpret this concept of difference between two sets using the knowledge of universal set concept and complement of a set. I beg you. Should you hear me, Abi? Difference of two sets is not the same as complement of a set. Please, because some persons might mistakenly want to use that interpretation of complement. Because if you're not careful, you will see a kind of relationship, closeness, as if the analysis is the same, but it is not the same. In this case of difference between two sets, there is no definition of universal set there. You don't have any special set that contains all these elements. Remember, when I dealt with number 3, complement of a set, we had a special set that contained two other subsets, A and B. And that special set that contained A and B, I called the universal set. Since it is that guy that gave birth to A and B. All the elements in A are inside that set. All the elements in B are inside that set. So I define that set as a universal set to A and B. In this case, there is no special set that contains the elements that are in A and the element in B. For that reason, you don't talk about complement of set here. Please take notes. Because if you look at this, you can't tell me that A is the universal set of B, and you can't tell me that B is the universal set of A, because there are some elements that A has and B does not have it. And there are some that B has that A does not have it. So none of this set contains the other one completely. For that reason, you do not use the knowledge of complement of a set, please. Let's go. So A difference B. Let us check the elements that A has, but B does not have. And what are the elements? A has 5, minus 5 rather. Is there minus 5 in B? No. So A difference B will contain minus 5. It's just like you going to A and remove all the elements of, B, but being careful anyway, because there are still some elements that B will have which are not in A. So the best thing is just to look at the comparison straight on. Look at them. Oh, this one is here, it's not here, you pick it. This one is here, it's not here, you pick it. So we move. A has minus 3. B has minus 3. So there's no difference there. A has 1. B also have 1. So there's no difference. A has the element 2. B does not have the element 2. So if you're talking about A difference B, 2 will be part of it. Once again, remember the definition. Elements that are in A, which are not contained in B. So we move on. 8. 8 is in both of them, so there is no difference there. Are you following, right? This is A difference B. Now let us find B difference A and see what we are going to get. B difference A. So this time around, we will go to set B and then check what are the elements that are in B but not in A. We go, compare. You have minus 3 in B. You also have minus 3 in A. So there is no difference. With respect to minus 3, no difference. You have 1 in A. You have 1 in B. So with respect to the element 1, there is no difference. You have 8 in B. You have 8 in A. No difference. You have 9 in B. You do not have 9 in A. So there's a difference there. It means that the set B difference A will contain 9. Please take note. You say that there are some elements that A has, but B does not have them. You can't pick those elements in B difference A. You can't. Understand it. B difference A means elements that are inside B, which A does not have. So you are focusing on the elements which are contained in B, but you cannot see them in A. You have no business with the elements which are in A, but B does not have. I'm saying this because when I moved from, 1 here, B has 1, A has 1. I told you there is no difference. Moving further, I saw that B has 8. A has 8. Notice that this number, I didn't consider it. I jumped it. Because A has 2, but 2 is not in B. Will I now bring that 2 here? No. Because that 2 is not inside B at all. Remember the whole idea of the difference. B difference A, element in B, which A does not have. And then if it is to be A difference B, it might be element in A, which are not, or which is not in B. So you want to be careful about this, please. You can't bring this 2 here, because this 2 has nothing to even do with B at all. What we are just picking out here are the elements that are inside this B, which you can't see in A. That's the meaning of B difference A once again. And the same goes with A difference B, just like I solved here. So quickly, let's conclude. Now, I have picked 9 because 9 is in B, but it is not in A. Next, you have 11 in B, but it is not in A. So you bring it. This is the definition of B difference A. I'm going to check the camera before I move on to number 5, symmetrical difference between two sets. But let me just tell you, the whole idea of symmetrical difference between two sets is to get the union of the separate difference. I repeat, symmetrical difference, symmetric difference between two sets. The symmetric difference between these two sets, all I have to do is to find black minus blue. Find blue minus black. That is, this thing is not ordinary minus, so I'm sorry that I've used pronounced it minus. It's just simply pronounced difference. A difference blue, black rather difference blue. Then do blue difference black. You get two separate sets like we obtained them here. Then unite both of them. That is the symmetric difference. Let me check the network situation quickly. Hi, can you start all over? No, I cannot start all over. Janet Matiti. How do you expect me to start all over again? I can do that. That would be a waste of time and unseriousness on my part. Please, you can check back. A copy of this live will be made available later at the end of this class. And apart from that, I have told you that if you go through the playlist, you would see full video lessons on sets. I've covered all this set notation before, just trying to highlight some things for you guys, okay? Let us now perhaps round off. Yes, I want to round off with number 5, symmetric difference. Symmetric difference. Symmetric difference, okay, between two sets. What is the symbol we use for symmetric difference of two sets? Symmetric difference of two sets. We use this symbol like triangle, okay? This delta symbol. Like I said, the idea of symmetric difference is simply the union of the difference between two sets. The union of the difference between two sets. And you must do this thing for each of the two sets. If I have this as two sets, and I want you to get a symmetric difference between them, do a difference, do this black marker difference, blue marker. Get that set. Do blue marker difference, black marker. Get that set. Then unite them together. So we're going to use this example here, right? From example 4. From example 4. Do I need to write that from example 4? I don't have to. Let me just say that from what we have here, right? I'm going straight to deal with this guy. A difference B is equal to, let me just write from above anyway, so that you know that I'm referring to this. From number 4 above. Number 4 above. The symmetric difference between A and B. A symmetric difference B, right? Is equal to, now you have gotten A difference B, look at the set. You have gotten B difference A, look at the set. So all you have to do is to unite both of them. So it's going to be minus 5, comma 2. Then union union 9, comma 11. Now if you have this union, this, you can actually put them together, if you so wish. This is going to give you minus 5, comma 2, and then 9, comma 11. Is that okay? That's the whole idea of symmetric difference. These 5 set notations I've treated, are they the whole concept of set notations? The answer is no. But of course, this is where our class will end today, under set notation. And I will not hold a proper live class on set notation again, I'll only do some, short video works on them. So you check the short section of this channel, you'll see works on set. I'll release as many of them as possible. Are you following? But to have the full study, like I said, please check the playlist on this channel, Math 101. You'll see a playlist dedicated to number system and set. There you have the full video lecture on set. If you're not a channel member yet, become a channel member so you can be able to access the videos, right? Complete work on set. If you're a Unizik student, you can register for tutorials, like I said. You get full access to them with many more benefits. Your workbook solutions. See, on this channel, all the solutions are available from A to Z. 30 marks for each course, don't joke. Your practical works, Chem 107, Phase 107, all of them, the whole works is available for what you're going to do during this semester, plus the exam-related questions, fully answered. So register with GMAETS 41's tutorial. We hold physical tutorial in case some of you that are being told lies. Yeah, I'm overhearing that some of you are being told that I don't run physical tutorial, it's only online. Beware. Get every information from GMAETS 41. Am I communicating? I have my classes 4 times weekly on campus. Monday, Tuesdays, Fridays, and Saturdays. Wednesday and Thursday, we use them for full personal studies and exam-focused revisions. Am I communicating? Don't be deceived. GMAETS 41 is right there with you guys. We have other set notations to include subsets of a set. And if you talk about subset of a set, we have types of subsets. You'll find out those things in the video lesson I told you about. We have proper subsets. We have improper subsets. We have supersets. Another set notation is power set. The knowledge of power set is actually obtained from subsets. So you need to learn about subset first before you talk about power sets. And of course, that reminds me of this wonderful formula that is used to obtain the cardinality of power set of a given set. Cardinality, this N represents cardinality, which means how many elements do you have in that set. Cardinality of a power set of any given set has the formula 2 raised to the power 2 raised to the power of cardinality of that set. So I can ask you, like this particular set now, this one that has B difference A, for example, B difference A, I can ask you to find the cardinality of the power set of this difference of these two sets. Find, like in this case, now let me ask the question even. What is the cardinality of the power set of B difference A? Of this set called B difference A. What is the cardinality? How many elements will you have? If you are counting, how many elements will there be in the power set of this A difference B? You know, this A difference B, if I ask you what is the cardinality is 2. Because there you can count 2 elements, 1 and what? 2. The power set now of this guy, what is the cardinality? How many elements will be there? Do you now need to punish yourself, pull out all the subsets and start counting? No, you don't do that. Once I give you any set and you know the number of elements in the set, if I ask you to find the cardinality of the power set of that set, it is simply 2 raised to the power of the cardinality of that set itself. So in this case, it's going to be 2 raised to the power of cardinality of A of B difference A. B difference A. And that, of course, is going to be equal to 2 to the power of, I hope this has not cut off. Let me check. All right. It's intact. So that is going to be equal to, you come over here, 2 to the power of, what is the cardinality of B difference A? You come here. B difference A, the cardinality is 2. You have 9 and 11, 2 elements there. So this is going to be 2 raised to the power of cardinality of that B difference A, which is also 2. So the cardinality of the power set of the set B difference A will now be equal to 4. Will now be equal to what? 4. So you see, Very simple. You play with it. You will meet all of these concepts in that video lesson, like I said. Power set, and then cardinality of power set. We've talked about complement of a set. I gave you the idea of empty set. Empty set is simply a set that contains no element. All right. So is there any other set notation that I've not highlighted? Like I said, you'll meet the rest of them in that video lesson. Please become a channel member, register with GMAETS 41. If you are joining the channel membership, please note, to get access to all of the video lectures or to get access to any special video lecture you need, you have to join on the diamond level. Nigerian currency, 4,000 naira per month only. I'm saying this because some of you are fond of, you will join any level you want. And then when you want to take a particular lecture, you are told to upgrade. You now start disturbing me. Yes, calling me out. Sir, I did channel membership. They are telling me to I should still upgrade. Please, the higher the membership, the more benefit you get on the channel. To access all the video lectures, you have to be on diamond level. Platinum level, which is 2,000 only, would only afford you just some video lectures. Like I said, for your physical tutorials, please contact GMAETS 41 to join our physical tutorials on campus, those in Unizik. We also have our special rock solid online class where I'll be guiding you specially. It is different from you deciding from wherever you are to become a channel member. Are you getting me right? It's different from that. For those ones that contact GMAETS 41 and then they apply for that special online class, they have wonderful packages for them. I love you guys. I want the best for you. I've always said and addressed you people as much as possible. Do the right thing. Don't just dream of success. Don't just dream big. Dream and then be intentional in achieving that dream. I'll be seeing you tomorrow. Good night. Remember to share this video to your friends and tell them to also subscribe and follow this channel, okay? Bye.